today we're going to do the last session in sequence and series, which is called a binomial expansion. We're going to do this in two ways. One is we're going to get the coefficients doing what's called Pascal's triangle, and the other thing we're going to do is do it through binomial theorems. So first of all, what is a binomial expansion? So binomial expansion is expanding binomials. Binomials are two numbered elements, like for example 2x plus y. So that's a binomial. And then I'm going to take it to a power, I don't know, say the fifth power. This will give me a series of things added together. In this case, you'll see in a moment, 6 terms. And what we're going to do is come up with a couple ways of coming up with the series itself and specific terms in it, just like we had for example, the explicit formula to do specific terms in a sequence. I'm going to do a couple of these first, and then I'll come back to how they're used. But let me first start with Pascal's triangle, which is one of the two methods we're going to go through. Pascal's triangle. Okay, this will actually, I think, look familiar to some of you. I usually use it as a riddle sometimes in geometry. I'm going to take just an arbitrary binomial, a plus b. A could be anything, b could be anything. And I'm going to put it to a certain power, in this case 0. If I do that, anything to the 0 is 1. If I now go to the first power, I get a plus b. If I go to the second power, I'm squaring it, and I get a squared, and if I FOIL this out, ab plus ab, which would be plus 2ab, plus b squared. Now if I do the cube, if you don't see that, this is a plus b times a plus b FOILed. Now I've got to do it cubed, which means I've got to take this thing and multiply it by another a plus b. Turns out if I get that, I'm not going to show it, it's a huge multiplication exercise, but I'll get a cubed plus 3a squared b plus 3ab squared plus b cubed. And if I did it to the fourth, I will get a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. Now if you look at this, you'll start to see some patterns, and we're going to use this to do the binomial expansion. Notice the first term in here is just going up a's. A squared, a cubed, a to the fourth. The last number is just going b squared, b cubed, b to the fourth. And then we're getting declining values of a in each term as we go this way. A fourth, a cubed, a squared, a, no a at all, or a to the 0. And rising values of b squared, b cubed, b to the fourth. In addition to that, you also see that we're getting coefficients that are 1, then 1, 1, then 1, 2, 1, then 1, 3, 3, 1, then 1, 4, 6, 4, 1. I'm actually going to write that down, just those coefficients, in a moment. But you may have recognized those numbers themselves as I said, the pattern we did in geometry. So I'm going to write those down without the a's and b's, just the numbers. 1, 2, take out the pluses as well. 1, 1, 3, 3, 1, and finally 1, 4, 6, 4, 1. This is called Pascal's triangle. Now, if you look at that for a little while, you might see a pattern, which is that every number in the last line or in a given line is the sum of the two numbers right above it. So for example, 4 here is the sum of 3 and 1. 6 is the sum of 3 and 3. 4 is the sum of 1 and 3. 3 is the sum of 1 and 2. 3 here is the sum of 1 and 2. So I could get the next line then if I wanted to. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And finally, the 1 just comes straight down because there's nothing over here. And there's my next line. And those are the coefficients of, if I did a plus b to the 5th. Okay, I'm going to try a plus b to the 6th. I want you to pause the video here and try to write the 6th line down there. All right, if you're back, 1 is there. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And 1. There we go. Now if I want to do 7th, 1, 7, 21, 35, 35, 21, 7, and 1. And I could keep doing those. Obviously, if I was doing something to the 20th power, this is basically a recursive formula. I need every line before it to get the 20th one. So that's not great from that perspective, but you can see how you would get those. And that only gives you the coefficient. But if you just then apply those rules, like for the a to the 7th, I could put this as a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a1. And then b's, I could put as b to the 7th, b6, b5, b4, b3, b2, b1. And I'd have the binomial expansion of a plus b to the 7th. Or in other words, the series of what a plus b to the 7th is. Okay, as I said, the only problem with this one is it's recursive, meaning I have to have everyone above it to get the next line. Now I'm going to give you a way of doing just a single line without doing the ones above it. Erase this. So this was Pascal's triangle, obviously, because it's a triangle, and it was invented by Pascal. So I'll write a little cheat sheet up here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, etc. Okay, the next one we're going to do is what's called the Binomial Theorem. And I'm going to write it down first, and then give you an idea of how to do. It'll look a little strange, because I'm not going to know some of the terms of how to do them. So I'm going to write it out first. This just says if I take a plus b to the n, again, what I was doing on the first page, I can simply do, this is going to be called a combination. I'll give you the formula in a moment. Put in big parentheses n0, a to the n, plus n1, a to the n minus 1, b, plus dot, dot, dot. I'll do the next one actually first. n2, a to the n minus 2, b to the 2, plus dot, 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 nr, this will be my general term, a to the n minus r, br, plus dot, 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 and the last term will be nn, b to the n. Okay, I would pause this and write that down. Obviously that's a bit of a mess. So write that down. Okay, if you're back, this is what's called the binomial theorem. So I'm going to erase, I'll put that over here. This is Pascal's triangle. Then I have the binomial theorem. Remember, theorem means it just needs to be proved. And this is a way to give an expansion. I'm going to go through each element of here in a moment. But let me just start with I'm going to come back to this. Let me start with these terms mean. This just says I start with, like, this is a to the 7th, this is a to the 7th. This is a plus b to the 7th, this is 7, n is 7 in other words. So this would be 7, that would be 7, this would be 7 minus 1 or 6, this would be 7 minus 2 or 5, next one would be 7 minus 3 or 4, and you keep doing that until you get to the last term, which will be the nth term where you actually just have no a at all, because it would be a to the n minus n, which is a to the 0 or 1. And then the other terms, the b to the n's, are doing what we did before. You start with b to the n last term, go backwards, this would be b to the n minus 1, etc., all the way back to b2, b1, and b to the 0. So that gives you the a, b's that we had before. So for example, I'll do an example in a moment. Let me go through this part here though. This is going to give you the Pascal triangle numbers. This is just going to give you, for example, if this is 7, this is going to be 1, this is going to give you 7, and etc. Just like the Pascal's triangle. If this was 3, this would give you 1, 3, 3, and the last one would be 1, 1, 3, 3, 1. What that means is, that little parenthesis in there, it is called a combination. This means the combination of n things taken r at a time. It's actually a probability term, and we'll use this in probability in Algebra 2 after this. And for those in college algebra, we already have this in probability. It means taking a certain number of elements, like 10 elements, and putting them together 3 at a time, for example, 10, 3, and seeing how many ways you can do that. In this case, there's actually just a formula for it, however, which is n factorial over r factorial n minus r factorial. And I know you don't know what factorial is yet, but make sure you write that down, and then I'm going to go what factorial is. Okay, so again, this is Pascal, this is binomial theorem. This is how you expand a binomial to a power, and it does require knowing what this is. this will give you the coefficients of Pascal's triangle. So I'm going to show you what this is first. First of all, what is factorial? N factorial, say 2 factorial, and that's, by the way, just an exclamation point, is the number itself times the number below it times the number below that, etc., until you get down to 1. So, for example, 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1, and then you stop. You can only do it for whole numbers. So 10 factorial, for example, is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, etc. These get to be really large numbers. We used to be able to blow up calculators just by putting 99 factorial. You get an error automatically. I think they can handle it now. But you can try it. There's actually a factorial button in the calculator. Okay, so that's factorial. So I'm going to give you an example of how you do one of these terms. And what in fact I'm going to do is try to generate one of the Pascal triangle terms with it. I'm going to do a simple one first. I'm going to generate this term right here, that 3. So what that term is there are 3n. In other words, this is the third line, 1, 2, 3. I'm making this 3. So n is 3. And then I'm going to find this is the 0th term, r0. This is the first, second, or third. So I'm going to find this term right here, not the 0th term, but the first term. So I'm going to do 3, 1 like this. What that means is it's a combination of 3 things taken one at a time. And that, if you just plug it in, is 3 factorial over 1 factorial times 3 minus 1 factorial. Or this is 3 times 2 times 1 over 1 times 2 times 1. Those cancel, and the answer is 3. In other words, that coefficient right there. If I wanted to find this one right here, this other one, that is the 0 first, second term, counting from 0. You get a combination of 3 things taken 2 at a time. It's 3 factorial over 2 factorial, this number here, times 3 minus 2 factorial, which is 1 factorial. That's just 3 times 2 times 1 over 2 times 1. That cancels, and you just get 3 again, so that's that term there. So that's how you find the terms. Let me do one more. I'm going to do the 3, 0. 3, 0 is 3 factorial over 0 factorial, 3 minus 0 factorial, which is 3 factorial. What I didn't put up here, and this is why I did this term, is that 0 factorial is defined to be 1. Just defined to be it, you don't have to prove it. So this is just 1, therefore this is just 3 factorial over 3 factorial, or 1, which gives you this term. So that's what this term in front means. You can use it by Pascal's triangle if you want. The only problem with Pascal's triangle is if you want to find the 50th line of this, it's a bit painful to write 50 lines out. Okay, so I'm going to try this with a couple examples. I'm going to leave this stuff up and just erase the bottom part here. Actually, I'll leave that up as well. Doesn't leave me a ton of room, but that's okay. So what I'm going to first do is expand just x plus 4 cubed using this formula. First of all, this means that n is 3 in this right here. R will be whatever term I'm finding, so it's not the fixed. It starts at 0, goes 1, 2, etc. until you get to 3. Okay, so let's start with I'm going to do the variables first. The first one is x, so this is a in my equation, that's b. That's x cubed, and then that's it. It's just a cubed. The next one will be x to the 3 minus 1, or x squared, and times b. b in this case is 4, so it's 4x squared. Give a little room because I haven't done the combination part yet. The next term will be x to the first, and the last term will have just x to the 0. Then, in addition to that x, you will have b squared, which is 4 squared. I should put the 4 back here. And then finally you get x to the 0, which is my last term, and then just 4 cubed. Okay. Those are the terms. Now I start with x cubed, x squared, x declining x, and the numbers climb up, starting with the second one, 4, 4 squared, 4 cubed. Now I have to get the coefficients, which I haven't done. I could use Pascal's formula, which just says 1, 3, 3, 1. Put those in front. 1, 3, 3, 1. That's all multiplication. This becomes x cubed plus 12x squared, 3 times 4, plus 16 times 3, or 48x, plus 1 times 4 cubed, plus 64. There we go. Okay, I'm going to do another one. Let's try 3x plus 1 to the 4th. Okay, so let me do the variable part first. 3x is a, 1 is b. So the first term is going to be 3x to the 4th. And the 3x has to all go to the 4th, including the 3 to the 4th. The next term will be 3x cubed, 3x squared, 3x, and then 3x to the 0, or 1. Then we're going to do the 1 part. That's easy. This is nothing. Then it's 1, then 1 squared, which is still 1. I'll actually put it in. 1, 1 squared, 1 cubed, and 1 to the 4th. And the last piece of this is to put in Pascal's triangle, or use the Binomial Theorem. I'm going to use Pascal's triangle again. 1, 4, 6, 4, 1. So it becomes 1, 4, 6, 4, 1. I'm going to just put the numbers in front here. Plus and plus. There we go. Oops, that was bad. I erased my 4. Okay, so now this is 3 to the 4th, which you can do in your calculator. Just get it's 3 times 3, which is 9. 9 times 9 is 81. So this is 81x to the 4th. The next one is, this is 3 times 3 cubed, so 27 times 4, which is 54, 108 x cubed. The next one is 3 squared, which is 9 times 6 is 54x squared. And this is 12x. And that's all 1. And there we go. There's my series, or my binomial expansion, for 3x plus 1 to the 4th. Okay, let's try another one. Actually, I'm going to have you do one. So a relatively straightforward one. See, x, 2x plus y, and we'll cube it. Okay. Pause right there. Try it yourself. Okay, if you're back, you have 2x cubed, 2x squared, 2x, and then 2x to the 0, which is 1. And then the y, we have nothing there. Y squared, y cubed. So again, this is 2x declining values of powers. This is y increasing from the second term, or you can think of it as coming from the end and declining that way. And now I put the coefficients in, which is just 1, 3, 3, 1 from Pascal's triangle, and add them up. And I get 8x cubed plus 4 times 12, that's 12x squared y. That's just 2 times 3, or 6, plus 6x y squared plus y cubed. And that should be it. Okay, we'll do one more. It's a little trickier, so let me write it down first. X minus 3y to the 5th. First of all, I need another line of my Pascal's triangle if I'm going to do that. Also, notice that you have to use a as x, and b is negative 3y, not positive 3y. So think of it as plus a negative. Okay, pause that, try to do it yourself. Okay, if you're back, start with x to the 5th, x to the 4th, x cubed, x squared, x, and then 1. And then start from the end, do it this time, y to the 5th. Oops, not y to the 5th, 3y, negative 3y to the 5th. And then negative 3y to the 4th, negative 3y cubed, negative 3y squared, negative 3y, and nothing. Okay, that's just the a's and b's terms up here. Notice I put negative 3y every time, not y and the 3 outside. You have to make, for example, in this term, you've got to square both the negative 3 and the y. Okay, and now I'm going to put my Pascal's triangle numbers in, which I've run out of room here. So I think it is, just put another line on here, 1, 5, 10, 10, 5, 1. So I'll put 1, 5, 10, 10, 5, 1. There we go. And put the addition signs in, and then I'm going to do this ugly multiplication. Okay, first one's not 5, it's just x to the 5th. Next one is negative 3 times 5, or negative 15x to the 4th y. The next one is negative 3 squared, which is 9 y squared times 10, which is 90 y squared. Oops, I missed the x. X cubed y squared. Then the next one is negative 3 cubed, which is negative 27 times 10, or negative 270 x squared y cubed. And the next one is negative 3 to the 4th, which is 81 times 5, which is 405 y to xy to the 4th. And finally the last one is 3 to the 5th, negative 3 to the 5th, which is negative 81 times 3 is 243 y to the 5th. So pretty ugly. There's my binomial expansion, my series of that. Again, notice when you're done, you get x to the 5th, x to the 4th, x cubed, x squared, x, no x. And then the last one is y to the 5th, 4th, 3rd, 2nd, y, nothing. The negative sign in here, notice what that did. It made alternating positive and negative signs. Positive, negative, positive, negative, positive, negative. There we go. All right, now we're going to do it for specific terms. I'm going to have to go back to using this. It's just a Pascal's triangle. I'm going to give a specific problem, which is, I've got that same x plus 2 to the y, 2y, except now I'm going to go to the 6th, and all I want is the third term. I don't want any more than that. Okay, so there's a couple ways. You could either do the Pascal's triangle again, but I'm actually just going to use this formula up here. So if I want the third term, what I want is, first of all, the term that's right after. This is the first term. There's the second term. There's the third term. So I want I have 6 total numbers. I'm doing the third term, which means r in this case is 2. 1 less than s because this is the 0th term. 0, 1, 2. I can also, by the way, all this is going to do is give me Pascal's triangle number for the third term, which I can get up here as 1, let's see, 6, looks like it's 15. So I'll put it, this is 15. And now I need this term, I need the a, which in this case is x. There's a, and there's b. X to the n minus 2, which is to the 4th, and 2y, in this case to the 2nd. That'll give me the third term. So again, let me go through how I got that before I get this number here, which I'm hoping is, I think it was 15. I'm taking this, n is 6. I want the third term, which means r is 2. R is just whatever term you're looking for, minus 1, because you start with 0. That gives me this term right here. Then I'm doing the third term. So this third term, this will be this to the, it'll be right here, the n minus 2. Again, the 2 comes from the fact that this is the 0th term. So it's n minus r. So in other words, 6 minus 2 is right there. And then r is 2, so that goes there. So this is n minus 2, right down here. And this is r itself. 6 minus 2 is 4, and 2 goes there. Okay, so now let me do these terms. This is x to the 4th. This is 4y squared. Over here, I have what I hope is 15. Put that in here, I get 6 and 2, I get 6 factorial over 2 factorial, 4 factorial. That is a mess, so it looks like a mess, but actually I can simplify it quite easily by doing this. 6 times 5 times 4, 3, 2, 1, but I can just write it as 4 factorial because those are all going to cancel with what's on the bottom of 4 factorial. So in other words, I could write this as 4, 3, 2, 1, but this is also 4, 3, 2, 1, and they cancel. Over here I have 2 times 1 for the 2 factorial. So those cancel, and I get 6 times 5 is 30 divided by 2, or 15. So there we go. 15 times 4 is 60, x to the 4th, y squared. I found just the third term of this sequence. So think of, again, this is an explicit formula up here for finding the third term. Okay, I recognize that was a bit confusing, so I'm going to do another one. This time, I'm going to do x plus let's just do a simple one, 2 to the 8th. So it's big expansion term, and I don't even know what the term is down there. And I'm going to do the 4th term, which I don't even have up here. Okay, so first of all, I need to set up the term. If it's the 4th term, n is 8, r is 4 minus 1, or 3. Because we're going to be starting again at the 0th term, 0, 1, 2, 3. Then we put in our values. So we've got x to the 8 minus 3, which is 5th. 8 minus 3. And then 2 to the 3. There we go. This is just 8. So this is 8x to the 5th, but I have to find this out. So I'm going to do that over here. Combination of 8 things taken 3 times is 8 factorial over 5 factorial, 3 factorial, or 8 times 7 times 6 times 5 factorial, or 5 factorial, times 3 times 2 times 1. These cancel with that cancels with that, and that term looks like it's 8 times 7, or 56. Okay, so this is 56 times x to the 5th times 8. Or 8 times 56, I'm going to get a calculator for that. 448x to the 5th. Kind of a mess. Okay, what I want you to do, that's just again the 4th term, not the whole thing. If I did the whole thing, I'd have 9 terms. I want to do the same thing, except I'm just going to change one little thing for you guys to do, which is I'm going to make this the 3rd term instead, and I want you to find out the 3rd term. Pause the video right here and try that out. Okay, if you're back, the 3rd term will be 8. 3 means r is 2. Then you get x to the 8 minus 2, or 6. And then 2 to the 2. Okay, the 8, 2 will give me 8 factorial. That's what I'm doing here. Sorry. 8 factorial over 2 factorial, 6 factorial, or 8 times 7 times 6 factorial, over 2 times 1 times 6 factorial. Those cancel. That's 56 over 2, which is 28. So this becomes 28 times x to the 6th times 4. And 4 times 28 is 112, I think. Yeah, 112 x to the 6th. Okay, hopefully you got that. Okay, so that's it for the lesson. I'm going to now give you the homework. So I have 2 cities, Algebra 2 and College Algebra. So for College Algebra it is homework 28, which is called Binomial Expansions. For College Algebra, I think we are up to homework 19. All right, that's it. Until next time. Thanks.